Hello all, welcome to PythoVibes YouTube channel. I'm excited to bring you videos focused on interview coding questions, providing answers and explanations. By watching these videos, you will enhance your problem solving skills and coding abilities. In today's video, we will dive into the fascinating world of Python generators. So let's look into what are generators. The generators are a powerful feature in Python that allows us to create iterable objects efficiently. These special functions can be passed and resumed during execution, allowing them to produce a sequence of values over time. So if we compare normal function versus generators, what will happen in regular functions? We used to use the return keyword there to return some values. So regular function execute and return a value, but in case of generators yield the values, temporarily suspend the execution, and remember its state and resume where it left off. This lazy evaluation approach provides memory efficiency and allows for iterative processing. Let's create a generators. Let's start by creating normal function and see how this normal function varies with respect to the generators. So let me create normal function. So I'm just using a name called countdown, and it accepts one parameter, and I'm taking one list to store my output in case of normal functions, and I'm appending these values into this list, and I'm reducing this n value here, and at the end I'm returning this because it's a regular function. So let me create an object for this regular function equals to countdown of. So I would be requiring 5. It has to count down from 5, 4, 3, 2, 1, like that. It has to give me the output. So what if I would print this regular function? It gives me list of values 5, 4, 3, 2, 1, like 5, 4, 3, 2, 1. This would be the output. Let me save this and run it. So we got the same output. So what is happening when we write this regular function? So we have, if we want the output, we have to store these values into one element, one object, any iterable object. So this is consuming the memory here, and we are returning at the last. So what is happening? It is executing and it is doing some process and storing it in the memory. So this way it consumes a lot of memory in case of regular functions. To overcome this problem, we can use the generators. How do we use the generators? How do we create the generators means, instead of return keyword, we will use the yield keyword here. So let me remove this list here and just yield n and reduce the n, and since it's a generator function, so we shouldn't keep return here. So even one yield statement is also existed, then that entire function would be called as a generator only. So what will happen if we directly print this regular function instance, then what will happen? It will only give us the generator object. Instead of returning these values 5, 4, 3, 2 or something, it will return me the generator objects. Let me show you. So let me execute and show you. So we got this generator object countdown has stored at this address. So if you want to access these values, what we can do to access the generator object values, we will use the next method. So using the next method, we can achieve or access the yielded values, whatever we have yielded using this function, we can use this. So since we have been counting down the numbers from 5 to 0, so I have just written 4 statements using the print and next methods, and let me try executing it and see the output. So we can see using generator also we got 5, 4, 3, 2, 1. But if we have to do this in the real time, this would be hectic because we can't come to know how many times we need to call this generator function, generator object using this next method. So to avoid that, we can iterate over this generator object using the for loop. So let me write it for number in generator function, and then just print the number, and I'm giving the n parameter as a just a space only, so that the numbers would come like this side by side, 5, 4, 3, 2, 1 with a small space only. So what will happen? Let me save this and run it. One second. So we got 54321. We also got the same output when we use the generator function. So here we can keep any number of yield statements in the countdown in the generators, but if we keep the same thing in the regular function, what happens? Whenever it encounters the first return statement, then onwards it just stop and it will terminate the execution, and it will return us whatever the output it has captured. So this is how we will create a generator functions in Python. So we also have a generator expressions. So generator expressions are similar to list comprehensions, but enclosed in the parentheses instead of the square brackets. So generator expressions are especially useful when we want to generate a sequence without storing all the values in the memory at once. So as a simple example, what I will do, generator equals to, so as I said, we'll be using the parenthesis. I just want the squares of the numbers in the range of 1 to 5 for x in range of 1 to 5. So what will happen if I would print it here? I'll just get the generator object location, but what I want the value actually. So if I want to yield the value, we can use the next method. So whatever the number of times we want, we can print it here. So when I saved it and run the program, I could see the output as 1, 4, 9, 16 because I have taken the range from 1 to 5 and this 5 is excluded. So till the 4 only it has considered, and it has given me the squares of these numbers. So 1, 4, 9, 16. What will happen if I would increase and one more time if I would call it? What happens? It will raise an exception called as stop iteration because it has crossed the length of generator values. So whatever the object has been stored, it has crossed that limit. So that is the reason it is throwing stop iteration exception here. What are the sample use cases of these generators? So for the first use case, we can say that it's a in case of memory efficiency, we can use the generators. So imagine we have a large collection of items and want to iterate over them one at a time. You can create a generator that yields each item instead of loading all the elements into memory at once. This is particularly useful when we're dealing with large list or database queries. So we can use these generators in case of memory efficiency. So the second use case is iterative processing. Generators enable iterative processing of data where we can work with one value at a time, and we can produce infinite sequences. So generators can create infinite sequences, and since they produce values one at a time, you can use them. It won't cause any harm. And fourth use case is producing data processing pipelines and parallel processing using threads. When we work with large data sets, processing the data in chunks. So these are all multiple use cases of the generators. So that's all, guys. To conclude this, we can say that generators are a powerful tool in Python that can greatly enhance your coding skills and problem solving abilities. By understanding their concepts and utilizing them effectively, you can write more efficient and elegant code. I encourage you to practice implementing generators in your own projects and explore additional resources to deepen your understanding. Stay tuned for more videos on interview coding questions and problem solving skills. Thank you guys for watching this video. If you found this video helpful, don't forget to subscribe to my channel for more content like this. Feel free to leave any comments, suggestions or questions you have for future video topics. Until next time, happy coding.